Welcome everybody. Today we're going to talk about section 1.1, sets of real numbers on the coordinate plane. There's a lot to do in this section, but I have confidence that a lot of the material in this section are things that you may have seen before. So if you have, that's great. Listen along. Maybe I'll add a little something to your knowledge. All right, so when we start counting, and you're counting with your mom, dad, your guardian, whomever's teaching you, people always start with the number 1, then 2, then 3. So 1, 2, 3, ... And these are called the natural numbers or counting numbers. These are a set of numbers that can go as high as you'd like. However, as we know, they are not a complete set of all the numbers we have. Because you get a little older, and the number 0 comes into play. So we take the natural numbers, and we add a number to the set. All right? And these are called the whole numbers. Now, the natural numbers are a subset of the whole numbers. Right? However, we also know that there are numbers to the left of 0. Right? So, when someone started playing with negative numbers, right? We call this set the integers. Now notice, the natural numbers and the whole numbers are both sets that are included in the integers. So we're only expanding our number set. Now we have an awful lot of numbers, right? But on our number line, right, it is wholly incomplete because we have the number 0 and we have the number 1, let's say, right, and the number 2, right, and we have numbers to this side as well. However, there's no numbers in between them. All right, so the numbers in between are defined as a divided by b, where a and b are whole numbers, and b does not equal 0, right? Now, the common term is fractions, and that's fine, but the mathematical term for these numbers is the rational numbers. And you can also define the rational numbers as decimals that either repeat or terminate. All right, because all the rational numbers would be converted to a decimal, will either repeat or they will terminate. All right, now notice the natural numbers, whole numbers, and integers are all rational numbers anyway, because if I say 5 over 1, that equals 5, an integer, right? If I said 0 over 16, that's 0, right? That's part of the whole numbers. Or I could say 10 divided by 2, again, which would be not 2, but it would be 5, right? So all these numbers are included in the rational numbers. Now, there are some numbers that have decimals that don't repeat or terminate. All right? The most common one people think of is pi, 3.14159 ... right? And it goes on and on and on. A couple of others I'll give you as examples. The square root of 2, the square root of 3 are all decimals that neither repeat nor terminate, all right? These decimals, right, these numbers you can't make into a fraction, so we can't call them rational. So if they're not rational numbers, they are irrational numbers, all right? And basically what we say is that we take the set of rational numbers and the set of irrational numbers. Now notice the irrational numbers do not include any of our previous sets. That's why I had to make, right, their oval separate from the rational numbers. No rational numbers can be included in the irrational numbers. However, what we say is that we can take both sets of those numbers and we turn this into the real number system. All right, and for the most part in this course, you are working in the real number world only. Only if you're given specific instructions will you be working outside of the real numbers. So you are to assume at all times that you are working in the real numbers unless otherwise specifically instructed. All right. So the real number system has been around for a while, but it is not the only number system we have. Some of you, if not all of you, might know that we have something called a complex number system or imaginary numbers, right? But we will not be working with those numbers in this class. All right, let's talk about the coordinate plane a little bit. All right, the coordinate plane, again, most likely you've worked with a coordinate plane before, but I'm going to start from the beginning just to make sure we all have the basics, right? We have an x-axis and a y-axis. All right. Ooh, that's a terrible y. I'll make a better y. Now, the coordinate plane is sectioned into 4 quadrants. There's quadrant 1. There's quadrant 2. There's quadrant 3. And there's quadrant 4. In general, the quadrants aren't going to mean a lot to you right now. However, when we get to trigonometry, the quadrants are going to come into play much, much more. So I'd love to tell you about them right now. All right. So I'm going to erase this real quick because I want to do some more with this coordinate plane. I want to plot just a couple of numbers. So I'm just going to. Now, basically, these x and y axes are number lines. The x-axis is a number line horizontally. The y-axis is a number line vertically. So unless otherwise specifically told, you assume that each of these little hash marks is 1, right? If I were to label this 2, this next one would be 4, and this next one would be 6. I am not doing that right now. I'm taking all of these as 1. So if I were to plot the point 6, 4, I would go positive 6, so I'd go to the right 6. 1, 2, 3, 4, 5, 6. And I'd go up 4. 1, 2, 3, 4. And I'd plot my point. All right. Very similar. -3, -5, -1, -2, -3. -1, -2, -3, -4, -5. And you plot your point. All right. So it's just a matter of x always comes first when you're plotting a point. It's x then y. For those that don't remember, I always say it's alphabetical order. But like I said, probably have seen that before. Something that you may or may not have seen before is that we can get the distance between 2 points. So for example, if I said I had the point 1, 3 and 5, 6, right? And I wanted to find the distance between the 2 points. All right, the first thing I would do, and it's not required, but when you're just beginning, I think it's really nice to draw a picture. So I'm going to plot the points real quick. 1, 2, 3, 1. Right, 1. There we go. 1 and 4, 5. All right. And that's the distance we're looking for. All right. So we do not know that distance. However, I'm going to change colors real quick to differentiate. We do know that horizontal distance, right? Because this is 1, 3, right? 1, 3. And this is 1, 2, 3, 4, 5, 5, 3. So this horizontal distance is 4 units. And we also know this vertical distance because I'm at 5, 3. That point up there is 5, 6. So we know that that is 3 units. Now, what did I draw? I drew not just a triangle, but a right triangle. And I can use Pythagorean theorem to say 3 squared plus 4 squared equals c squared. 9 plus 16 equals 25, which equals c squared. I can square root both, and I get c equals 5. Right? So this is basically the way you find distance. Now, in your book, there is something called the distance formula. All right? And the distance formula basically says, that's my distance. So if I have c squared equals a squared plus b squared, right? And my a is 4 and my b is 3. However, I got that a by subtracting, right? So I had what? This was 1, 3, and this was 5, 3. So I subtracted x, right? My second x from my first x. So if I have c squared equals x2 minus x1, that's a terrible x. I'm going to make a better one. x1 squared. And then for my vertical distance, I went from 5, 3 to 5, 6. So I took my second y, 6, and subtracted my first y, 3. Right? I had a plus in between. So plus y2 minus y1 squared. But I don't want my c squared. I want my c. So what do I have to do? I have to square root everything. And all they say is that because this is a distance formula, I'm going to make it equal d. All right, but it comes from the Pythagorean theorem. I quite honestly feel that drawing a picture is probably the way to go. I've never been big on memorizing formulas. Quite honestly, I always mix up pluses and minuses when I was sitting in your chair. So I think drawing a picture is the way to go. But as you can see, if you decide to memorize the formula, right, at least you guys know where it comes from. All right, so let's try a quick example, then we'll move forward. All right, so my example is I have 2, negative 4, and I have negative 1, 3. And the first thing I suggest is to graph it. Right? And then we're going to find our horizontal distance, our vertical distance, and get the distance between the 2 points. So let's pause the video right now, make a quick graph, and then I'll graph it on the back end. All right, so let's take a look at the graph, right? I'm going to make quickly my x and my y axes. 1, 2, 1, 2, 3, 4, plot a point, and negative 1, 1, 2, 3, plot a point. Again, the graph is a sketch. The graph is a vehicle to better see this problem. So in order to make your vehicle as good as possible, you can always use a straight edge. I would always suggest having a straight edge around for this class. This class, you're going to do an awful lot of graphing. So it's something that could come in quite handy. All right, So the first thing we need is we need our horizontal distance. Okay. And if I'm going from 3 to -1, I'm looking at 4 units of distance, right? Now I need my vertical distance. Yeah, that didn't quite go through -1 like I had hoped. So I'm going to do the math teacher trick, and I'm just going to put -1 over there. There we go. So my vertical distance, I'm going from -4, right, all the way up to +3, right? So if I subtract the 2, I get 7 units. Yes? Okay. So now let's do, I'll call that D to make it distance. Let's do the Pythagorean theorem. So I have 7 squared plus 4 squared equals D squared. That's 49 plus 16 equals D squared. And 49 plus 16 is 59, 65 equals D squared. Oops. How's that? Wait a second. That's 3 units. Uh-oh. So now to keep me honest. All right, so this is 3 units, which means I got to change this. So that's 3 squared. Hey, listen, you know, sometimes you get them right, and sometimes you got to double check. So 49 plus 9 is now 58, and then I do the square root, and I say D equals the square root of 58. And as long as the square root of 58 is in lowest terms, this is most definitely your final answer. I would always double check. I ran through this a little quickly and messed up my horizontal distance. All right, but like you see, do a quick check and you can change things. All right, so let's go to the midpoint formula. Now, the formula for midpoint's a lot easier to remember. The midpoint of xy equals, now this formula is written kind of like coordinates. So my x coordinate is going to be x1 plus x2 divided by 2. My y coordinate is y1 plus y2 divided by 2. And that's going to find your midpoint. And like I said, I've always found this one easier to remember. So the example I'm going to give you is, I'm going to have 4, -2, and 2, -5. And then we're going to find the midpoint. So if I take the two x's and add them up, I get 4 plus 2 over 2. Take the two y's and add them up, I get -2 plus 5 over 2. And again, I want to put everything in most simple form. This is something you want to do for any problem that you're confronted with, because if you're going to work with numbers, you always want to work with them in most simple form. So 4 plus 2 is 6, divided by 2 is 3. -2 plus -5 is -7, divided by 2 is -3.5 or -7/2. Either one is fine. All right. So here's kind of a quiz question I could give with the midpoint formula. I could say something like this. Find the endpoint of the line segment with endpoint of -3, 6 and a midpoint of -1 comma 5. All right. So this is, like I said, kind of a quiz question. Why don't you pause the video and try to set this up a little bit. We'll work on it together in just a minute. All right, hopefully you worked on this a little bit. Now remember, the midpoint formula says my midpoint coordinate, -1, equals the addition of the two x coordinates. So I have one that I don't know. We'll call it 0.2. So x2 I don't know. But I'm going to add that to -3 because that's the one I do know, divided by 2. Now if I multiply both sides times 2, I get -2 equals x2 minus 3. And then I add 3. And I get 1 equals x2. All right, now let's try that same thing with the y values. So my midpoint, my y value in the midpoint is 5. So 5 equals, now I want to add up the two y values from my endpoints. So one of them I don't know. Remember, if I say the first one was x2, this is y2, plus 6 divided by 2. Now I'm going to multiply both sides times 2, and I get 10 equals y2 plus 6, and then I subtract 6, and I get 4 equals y2, and hence my midpoint is 1 comma 4. The best way to check your work, as always, is to graph your two endpoints, right? So this is endpoint, right? Endpoint number 2, and there's endpoint number 1. Graph the two endpoints, graph the midpoint. If it looks good, it's probably fine. All right. Now, one of the more important things that we're going to do in this section is we're going to talk about interval notation. Now, the reason I consider it important is it's something that you might not have seen before, number one. And number two, when appropriate, the expectation is that you will use interval notation. All right, so for example, you might see something like a less than or equal to x less than or equal to b. All right, this is called inequality notation. All right, and there's nothing wrong with inequality notation. It's just different. I just want to expose you to another option, and I want to get you comfortable using it. All right, hopefully after you get comfortable using interval notation, you'll be able to use both of them interchangeably. But like I said, for this class, when appropriate, I always want things in interval notation. Now, interval notation, all right, uses a series of brackets and parentheses. So for example, with this one, right, or equal to means a bracket. So I have a bracket A comma B in this case. And basically what this is saying is the same thing that this is saying. X could be any value between A and B, and it could be A and it could be B. All right? And this is called a closed interval. No matter what notation you use, it's called a closed interval, because the x value could be, there is definite starting and stopping point at what the x value could be. Could be A, could be B. All right. The next option we have is we have A less than X less than B. This is called an open interval. All right. And the reason this is an open interval is because in this case, X could be infinitely close to A, but it can't be A. So we don't necessarily have a definite stopping point, right? Because you can get infinitely close. That's so close, right? And the same thing with B. So we can't use brackets, right? If we use brackets, we'll think it's a closed interval. So what we do is we use parentheses. I say parenthesis A, comma B. And this says the same thing that this says. X could get infinitely close to A. infinitely close to b, but not hit them, and it could be any value in between them. All right, now the other option we have is our interval could be half open or half closed, depending on your outlook. So I can have a less than or equal to x less than b, right? And this is called half open. Right, where because we have the or equal to, I can put the bracket for my a, but I don't have it here, so I put the parenthesis. All right, and right, and I can do this very similar thing like this. Still, it's a half open or half closed interval. So I have a, b, and this side gets the bracket. All right. So I'm going to give you a couple of examples, right? Pretty straightforward. I just want you to get you comfortable with the brackets and parentheses. Two less than x less than 7. Third example is x is greater than or equal to 6. Fourth example, x is less than -3. All right, so at this point, I'd like you to pause the video and give these a try. Just convert them to interval notation. All right, hopefully you paused the video and worked through these examples. Shouldn't have taken that long. For the first one, pretty straightforward. It is a closed interval on both sides. You have bracket and bracket. And number 2 is an open interval both sides, like that. Now the third one looks a little bit unique. Basically what it's saying in the inequality notation is I can equal 6 and I can be any value greater than 6. So if I can equal 6, I need a bracket. But if I can be any value greater, I've got to go to infinity, right? Because x could be 1,000,000, could be 1,000,000,000, could be 1,000,000,000,000, right? And so on and so forth. The key is infinity always gets a parenthesis, all right? We can't achieve infinity yet. We're working on it, don't worry. But until we can achieve infinity, we can get infinitely close, but we can't achieve it. It has to always get a parenthesis. Now the last one says x could be less than or less than -3, which basically says it could be any number less than -3. All the way up to -3, but it can't hit -3. In that case, it would have a parenthesis on both sides, because very similar to positive infinity, negative infinity always gets a parenthesis. All right, one last thing that you do need to remember, and a lot of people forget, so I just want to do it very, very quickly here, is you got to remember the order of operations, right? Right? And your order of operations is a very common mistake that a lot of students make, and it's just simply because it's not at the forefront of their brain. So right, PEMDAS is the memory device, and each one, so this is parentheses. Next is exponents, multiplication, right? After multiplication is division, addition, subtraction. All right, so I'm going to give just a couple of quick examples, and I'm going to ask you to work through them, keeping in mind the order of operations. So it's 3 times 2 to the 5th plus 4. Second one is 5 minus 3 minus 1 squared. And the third one, Okay, just 2 is fine. All right, so why don't you pause the video, work through these examples, and then we'll take a look at them together. All right, so if we're looking at this, right, I've got a multiplication, I've got an exponent, and I've got an addition in the first one. So according to my order of operations, my exponents come first. So 2 to the 5th is how much? 2 times 2 is 4. 2 to the 3rd is 8. 2 to the 4th is 16. And 2 to the 5th is 32, right? So that's 2 times 2 is 4, times 2 is 8, 16, 32. So I have 3 times 32 plus 4. I'm a big fan of rewriting the problem after you do each step in your order of operations. If you try to do too much at once, very often you're going to wind up making a careless mistake. All right, so now 3 times 32 is 96 plus 4, right? And 96 plus 4 is 100. All right, now here in the second problem, I've got something in my parentheses, so I'm going to have to do that first, right? 3 minus 1 is 2. 2 squared is 4. So I have 5 minus 4, and I wind up with 1. All right, so that's pretty much in a nutshell what we have in section 1. There is much more practice to go. I look forward to seeing you guys in class and doing some more examples. All right, thanks for listening.